My name is Harrison Hensley, and I will be presenting on data centers and green computing. Our textbook defines green computing as the practices and technologies for designing, manufacturing, using, and disposing of computers and other IT equipment in order to minimize impact on the environment. Some examples of green computing include, but are not limited to, recycling or minimizing electronic waste, writing more efficient code. More efficient code means less workload for a computer, which means less energy required for that computer to do its job. Virtualization and cloud computing, which allows a single computer to accomplish more, resulting in less energy consumed. More efficient chips, for example, the Apple M3 chip has more performance per wattage than other competitors. And last, refurbishing electronics. Purchasing refurbished electronics can give a second life to what might otherwise be sitting in a landfill. Next, we need to understand what data centers are. Our book defines data centers as a facility that houses computer systems and associated components, such as telecommunications, storage, security systems, and backup power supplies. In essence, data centers are factories for large amounts of computing. There are thousands of data centers in the world with a total global capacity of over 120 gigawatts. In the Cincinnati area alone, there are at least 20 data centers. Now let's look at the different components of a data center infrastructure. First, the servers. These are performing the computing. Next, storage helps keep the data secure and organized for easier access. Networking handles incoming requests from customers as well as the outputs. The power supply is how data centers get energy that allow the servers, storage, and networking to operate. Next is environmental monitors and controls. This is primarily cooling systems for data centers. If you've ever felt a laptop heat up, you know that computers can produce heat. Data centers have a lot of computers, so they produce a lot of heat. Cooling measures are put in place to prevent overheating. Next, redundancy measures are put in place as a backup in case something happens. This includes backup to power supply, servers, networking, storage, and cooling. As I mentioned on the previous slide, computers use energy and produce heat, which requires cooling, which requires more energy and resources. Data centers use a lot of computers, so this issue is magnified. Data centers are responsible for about 1.5% of global energy consumption and over 4% of US energy consumption as of right now. However, AI is driving demand for computing power, so even more resources are needed to advance and use this new technology. Some estimates believe that AI will increase demand by double. We're seeing the impact on climate change more and more every day. So finding sustainable solutions to power these data centers is more important than ever. Consumers are also starting to connect the dots on the environmental impact of AI. Making data centers greener is a huge lever that humans can pull to reduce our carbon footprint and negative impact on this world for all inhabitants and future generations. There are a lot of ways that data centers can improve their green computing. It's important to note that green computing is not an all or nothing endeavor. Implementing smaller, incremental changes have a huge impact and are better than doing nothing at all. It's difficult to reach a destination if you don't know where you currently are or where you are even going. In my opinion, the first step a data center should take to establish green computing is to set up measurable green computing goals. This should be followed by an audit to see where the areas of improvement are. Some key metrics that data centers use for green computing include CUE, PUE, and WUE. These measure the carbon, power, and water usage effectiveness. Finally, there should be an investment in data center infrastructure management software that supports green computing metrics so that they can continue to monitor and measure these important KPIs. There exist both hardware and software solutions to improve data center green computing. First, let's talk about hardware. The Arista and Cisco Nexus are both data center switches designed to move data. They have comparable specs, except the Arista consumes 66% more energy. This may not seem like a lot, but it can add up fast. If a mid-sized data center has about 500 units of these devices, the annual carbon savings would be the equivalent to the annual emissions of just under 100 average cars. Large hyperscaler data centers have thousands of these devices, resulting in even more impactful carbon footprint reductions. However, there are trade-offs. In this specific case, the Cisco model has higher latency, meaning that it takes longer for data to transfer. The Cisco model is often more expensive upfront. Google's DeepMind is an example of an internal software solution. Google leverages their AI-powered DeepMind software to optimize the various cooling techniques used in the data centers. This has reduced their cooling energy consumption by nearly 40%, drastically improving their PUE. Energy source is another lever that can be pulled by data centers. The most common energy sources today include coal and natural gas. They are accessible and cheap, but come with heavy environmental impact. Renewables are also an option being used more lately. Grids used by data centers can incorporate renewables, and some data centers are even putting these renewable energy sources on site. However, these solutions are not perfect. Both require storage solutions. The sun is not always shining, and the wind is not always blowing. The energy, therefore, needs to be stored for when it will actually be used. Nuclear is a very safe and clean option that is being explored more and more, especially by large data centers like Google, Amazon, and Microsoft. The downside is the battle against the public perception of safety due to high-profile incidents in the past. Safety technology, however, has come a long way. Disposal of nuclear waste is also a challenge. There are also ways to improve backup energy sources. Currently, data centers use diesel generators as a redundancy measure. Fuel cell technology, such as hydrogen fuel cells, can be a cleaner but far more costly option. Cooling systems are responsible for about 50% of a data center's energy consumption. One technique to reduce this footprint includes liquid cooling or immersion, which is placing the hardware directly into certain liquids to manage the heat. Another solution is direct-to-chip cooling, which involves placing cooling devices directly on the chips being used. A third technique is free or natural cooling. This involves building data centers in locations that are naturally cold and using that cold air to cool the computers. This is why there are data centers that can be found underground or in very northern locations. There are several cooling techniques that are being explored for potential future use. One is the use of algae as a coolant. Algae naturally absorbs CO2, can recirculate water, and absorb heat, making it a very green solution, both figuratively and literally. There are also some extreme methods of free cooling, like putting data centers under the ocean or even in space. Undersea data centers have been successfully tested recently by Microsoft. We are still a few years away from space data centers, though. But the idea is that space is both cold and has great access to the sun, which is prime for solar power. It's a great example of how green computing is an ongoing quest with continual improvements as technology advances. If you're interested in getting involved with green computing, there are plenty of steps you can take. A great first step is to recycle your old electronics at one of the several reboot drop boxes throughout Cincinnati, or at the Cincinnati Recycling and Reuse Hub just west of downtown. No effort is too small. Even doing a little bit can go a long way and is much better than doing nothing. Some discussion questions for the class. First, if you were building a data center and were able to choose the energy source, which would you pick and why? Next, AI is driving substantial demand for energy and water. However, some believe that the technology will help scientists provide solutions to climate issues or directly help data centers reduce their energy consumption, like we saw with the Google DeepSeek example. Do you think that there will be a net benefit to AI when it comes to the environment or sustainability? Third, do you think that we will see data centers in space in our lifetime? And last, what are ways that you personally or your company can do to improve when it comes to green computing? I'm curious to read everybody's answers. Here are some of the references I used in this presentation. Um, a lot of the research that I found did not make the cut for the final version of this presentation. So if you have any other questions or are curious, let me know in the discussion board, and I'd be happy to try to answer your questions. Here are the rest of the references that I used in this presentation. And with that, I would like to thank everybody for watching, and I look forward to reading everybody's responses. I hope after this video, you have a greater understanding or appreciation of data centers and the advances that are being made in green computing. Thank you.